Last chapter we solved a lot of equations that look like this. 3x minus 4 equals 11. You see one here, the answer is x equals 5. When you have an equation like this with one variable, you get one solution. Today we'll look at when there are two variables. What happens, how do we deal with that algebraically and graphically? Okay, let's talk terms. We call a graph sometimes the rectangular coordinate system or the XY coordinate system. It consists of two number lines, one horizontal, one vertical, and they intersect at 0. The x-axis is the horizontal one. It has 0 in the middle, goes horizontally. The y-axis is then a number line that goes vertically with 0 in the middle. The origin is the point in the center, 0, 0. Our coordinate system is separated into 4 quadrants. The quadrants are labeled with Roman numerals. Starting in the upper right, that's quadrant 1, then upper left, quadrant 2, and then down to quadrant 3 and over to quadrant 4. Those are the quadrants. An ordered pair is written like this, with parentheses, 2, 3 would show a point on the graph. This first number here, the 2, is the x-coordinate, and the second number here, the 3, is the y-coordinate. It's kind of like Battleship. You find 2 on the x-axis and 3 on the y-axis, and their intersection point is 2, 3, and that's how we name spots on a graph. I've labeled the points A, B, C, and D for easier labeling. When we're graphing ordered pairs, you have the x-coordinate first and then the y-coordinate. So go to the x-axis and find -2. Go to the y-axis and find 4, and then pretend you're playing Battleship. It's that intersection point. And that will be point A. Point B, again, we've got the x-coordinate and then the y-coordinate. So you go to the x-axis and find 4, the y-axis and find -2, and it's their intersection point. Right there, that's point B, down in quadrant 4. Point C, again, the first number is the x-coordinate. The second number is the y-coordinate. So find 0 on the x-axis, -3 on the y-axis, and their intersection point is right there. That's point C. Point D, you find 4 on the x-axis, 0 on the y-axis is right there. That's point D. Pause the video and take a minute to put in dots where I have them located. Now we are going to tell the ordered pairs that go with each of these dots. So let's start with E. To do that, you just look what's the x-coordinate and the y-coordinate that go with that dot. So the x-coordinate is 5, y-coordinate 1. Again, think Battleship, the intersection of the x and the y-coordinate. Up here, F, the x-coordinate, follow it down, is -5. The y-coordinate is 6. So our ordered pair is -5, 6. You need the parentheses around it. G, the x-coordinate followed up to where it would hit the x-axis is -2, y-coordinate -3. So x is -2, y is -3. H, the x-coordinate where it lines up on the x-axis is 0, and the y-coordinate is 3. So this point is named 0, 3. Now that we've looked at graphing points, we're going to talk about how equations and points and graphs are all related. We'll be talking about using two variables, x and y, and using points to show how those lines look. We will be looking at linear equations mostly today. Those will look like this. You can also make graphs of nonlinear equations. You would cover these in higher algebra. So now we'll talk about how ordered pairs and points on a graph relate to equations. A solution of equation with two variables in it, like y equals negative 2x plus 1, is an ordered pair when you put the x coordinate in for x and the y coordinate in for y makes a true equation. You're going to have problems in your homework that ask you things like, is negative 3, 6 a solution to the equation y equals negative 2x plus 1? To figure that out, just put the x coordinate in and see if you come out with the y coordinate. I'll show you what I mean. If I sub in the x coordinate, negative 3, into this equation, what do I get? Negative 2 times negative 3 is 6. 6 plus 1 is 7. So what did I get out for a y value? I got out 7. It's supposed to be 6. Therefore, this is not a solution to the equation. Negative 3, 6 does not work for this equation. So let's try negative 3, 7 over here. So if we put in negative 3 for the x value and 7 for the y value, do we get a true equation? Well, if you put in negative 3 for x, negative 2 times negative 3 is positive 6. 6 plus 1 is 7. 7 equals 7. So yes, this is, that's supposed to be a yes, this is a solution to the equation. Let's try to find another solution to the equation y equals negative 2x plus 1. All we need to do is find two numbers that work. So I'm just going to randomly pick, well, let's pick x equals 4. So if x equals 4, let's just sub that in and see what y value we get out. Negative 2 times 4 is negative 8. Plus 1 is negative 7. So the y value, if x is equal to 4, the y value is equal to negative 7. So our ordered pair of another solution would be 4, negative 7. Now we can graph these 2 points. Negative 3, 7, that's right here. And x equals 4, y equals negative 7 is down here. So those are 2 points that are solutions to y equals negative 2x plus 1. So your homework is going to ask you questions like this. Find the solution of y equals 5x minus 10 when x equals 5. So all you have to do to answer that is find the y coordinate that goes with that. So sub 5 in for x. Five times 5 is 25, minus 10 is 15. So the y coordinate when x equals 5 is 15. So the solution that goes with x equals 5 is 5, 15, is a solution to the equation y equals 5x minus 10. Now back to our previous example. We're going to work again with the equation y equals negative 2x plus 1, and we're going to look for patterns on our graph. we're going to sub in these numbers here in for our x and find the y values that go with them. Then we're going to graph our ordered pairs and look for a pattern. I've put my x coordinates into the table, and now I'm going to find the y coordinates that go with them. To do that, I just sub the x values in our equation instead of x. So -2, that's from the formula. I'm subbing in -2, that's my x value, plus 1. Again, I'm just taking this equation, subbing -2 in instead of the x. So -2 times -2 is 4, positive 4, plus 1 is 5. So my y value that goes with -2 is 5. So that means that one point on my line, or one point that I know is a solution to this equation, is x equals -2. Oh crap, that's 4. -2, 5 is right here. That is one solution to my equation. Take a moment, stop the video, and do the work to find the y values of the other x values that are given. There's the work for the other y values corresponding with x equals -1, 0, 1, and 2. And now take a minute to stop the video and graph all these ordered pairs. And then from our work up at the top of the paper, we have 2 more points to add to our picture. And you can see that this pattern makes a line. This is called a linear function, a linear graph, and we'll talk more about that in days to come. One last thing before we go, your homework is going to talk about something called function notation. And that is just a mathy way of showing equations. And instead of writing y equals 2x minus 3, they're going to say f of x. This is read f of x equals 2x minus 3. It's just like saying y equals 2x minus 3. Another thing that they're going to ask you is find f of 2. What they really mean is, what will the y value be when x is 2? So if you want to answer the question, find f of 2, you just sub 2 in for the x value. So using 2x minus 3, we're going to sub 2 in instead of x. 2 times 2 is 4, 4 minus 3 is 1. So f of 2, putting 2 in for x, gives us a value of 1. So my answer would be 1. Another example, let's find f of -10. That just means take -10 and put it in for x into my equation. 2 times -10 is -20. -20 minus 3 is -23. I've just replaced my x with -10. So f of -10 means put -10 in for x and find what the y value would be, -23.